Hi guys, another question from section 3.4. It was number 15. So again, don't forget the same question. We do have to look for the absolute maximum and absolute minimum of this function over the given closed interval. In this case, in number 15, our function f of x happened to be x cubed minus x to the 4. Okay, and of course the interval that we are restricted by is the interval -1 to 1. Again, don't forget, we only worry about this the absolute maximum over this interval, right? So as I mentioned in last video, first thing, of course, is there's only two places that the absolute maximum minimum can happen, either at the critical values, again, within this interval, or at the endpoints. Don't forget the endpoints. So first step to find the critical values, of course, we need derivative. So we'll differentiate this function, which becomes 3x squared minus 4x cubed. So as again, you know by now, to find the critical values, we have to set the derivative equal to 0 and then solve for x. So you can see, of course, both term has a factor of x squared. So as you pull x squared from the first term, leaves you with 3. As you take out x squared from second term, leaves you with -4x. So now we're going to set each factor equal to 0. Either x squared is 0 or our second factor, which is 3 minus 4x equals to 0. But of course, x squared goes 0 means x is plus or minus the square root of 0, which of course is just going to be 0. And then also, as you move the 3 over to isolate the x, that becomes -4x equals to -3. Then we'll divide by -4 to solve for x. And so, of course, -3 over -4, which becomes 3/4. So we do have two critical values, and if you notice, 0 and 3/4, they both happen to be between -1 and 1, because of course 3/4 is less than 1. Also 0 is between -1 and 1. So in this case, we'll have four values we have to consider. So let me go ahead and go up here. So I'm just going to put them here and then I'll give you the values, okay? So first of all, don't forget, you always have to find the function, evaluate the function at the critical values that lie in your interval. Of course, in this case, both of the values do lie in the interval. So we do have to find f of 0. We do have to find f of 3/4. And then, of course, don't forget, you always have to include the endpoints. So f of -1, and then also f of 1. And so that's pretty much it. So once you find these four values, as I said before, the largest value among these four will be your absolute maximum, and the smallest your absolute minimum. Okay, so as you plug in these values, this becomes 0 cubed minus 0 to the 4, which of course is just going to be 0. F of 3/4, it'll be 3/4 cubed minus 3/4 to the 4th power. And by the way, most of the time they do want the answer in fraction form. So you do have to do a little arithmetic here with fractions, as I'm sure all of you know, of course. So this becomes 27, as you cube 3, of course, over 4 cubed, which is 64. And then minus, as you raise 3 to the 4th power, I believe is 81. And then 4 raised to the 4th power, which becomes 256. So now, of course, between 256 and 64, obviously, the least common denominator is 256. So we're going to multiply top and the bottom by 4. So we can make 64 to become 256. So then we can combine them to a single fraction, okay? Now, 4 times 27 becomes 81. 108 over, of course, 256. But then also we have 81 over 256. So now that you have the same denominator, you can actually combine them to one fraction. That's the reason why we wanted the same common denominator. 108 minus 81, I believe, is 27. So 27 over 256 is pretty much the value. Now, again, you can approximate it, but I think most of the time, they want the answer in fraction form. I'm going to move these two down a little bit so we don't get them mixed up with this value. So far we have found two of the values. So now we need to also, don't forget, find f of the endpoints, f of -1, which of course, as you plug in -1 in place of x, well, -1 cubed remain as -1. -1 to the 4th become +1. And of course, -1 minus 1 become -2. And finally, f of 1. Again, going back to the original function, that's 1 cubed minus 1 to the 4th. 1 cubed is 1. 1 to the 4th is also 1. So that becomes 0. Okay, so So now you can see, of course, between the four values, well, two of them are 0, of course. And the other one, well, this is positive, 27 over 56. And of course, -2 is smallest, right? So the absolute maximum, because again, 27 over 256 is larger than 0. So that's your absolute maximum. And of course, -2 is your absolute minimum. Okay, so let me go ahead and again finalize this. So now we can say I'm just going to start it here. Absolute maximum equals 27 over 256. Now remember, that happened at the x equals to 3/4. So we're just going to also add at, because they always want to know where does it happen. Of course, in this case, it happened at x equals to 3/4. And we can also see that in this case, f of -1, which is -2, is your absolute minimum, which happens at -1. So I'm just going to go ahead and write absolute minimum equals to -2. Let me just put it here. Equals to -2, and of course it happens at x equals to -1. Okay, so this kind of will be your conclusion for this problem, of course, after your computations. Okay, so we have absolute maximum is 27 over 256, which happened at x equals to 3/4, and absolute minimum is -2, which happened or occurs at x equals to -1. Okay.